In this video, we're going to go over the idea and understanding of what it is to advertise routes into BGP. And you've seen a couple of them advertised already. We've taken a look at Redistribute Connected, where we've gone in and redistributed routes in. You get the question mark when you do that, which means it doesn't know where the route was originated from. It just knows that it was originated, and that that's your indication. If it's a question mark, that it was redistributed. Or at least it looks like it was redistributed. And the reason why I say that is you can actually change the origin code to make it look like it came in. You can the origin code makes it. You can change it to make it look like it was an origin of IGP or it was redistributed in, but just by changing the origin code. So, what is NLRI? Well, NLRI, or Network Layer Reachability Information, is simply a route. It uses update and withdrawal messages to exchange network layer reachability information. So there's a few different ways you can do this with the network statement, and this requires an exact match in the routing table first. So what this means, and what I mean by routing table is I mean global routing table. So the idea behind this, well, technically speaking, it could be the BGP routing table, but you may not be advertising any routes into the BGP table. But you still can get routes that are directly connected to your router, but not in the BGP table, into BGP, by using the network statement. The caveat with the network statement is you would have to do a show run interface, whatever the interface is, to make sure you have the right subnet length. So whatever the mask length is what you need to specify inside of your mask command. So whatever your IP address is, and the network and the subnet mask is on the interface level, that needs to match. So you type in 10.1.1/24, and you go to BGP and you type in network 10.1.1.0 mask 255.255.255.0. That's going to match that particular interface, and it's going to turn BGP on that interface and allow you to advertise that route in. Now, redistribute statement is a little bit different. You can do a redistribute connected, which is going to take every physical interface you have and redistribute it into BGP. Even if it's redistributed into another protocol, it's still going to redistribute that into BGP. However, by default, it will not include external Ospf routes. And if you want to include them, you would have to do match internal or match external in the redistribute command. But typically, what you're going to do when you do your redistribute connected is you're going to go in, and I'll take, there's a question about redistributing a IGP into BGP, and I'll get to that in just a moment. When you're doing a connected route, though, or connected interface, you would usually call a route map when you're doing this, and the route map would be matching a particular interface or interfaces, and you could go then and then advertise it in. At the same point in time, you could do a redistribute Ospf and Ospf1, and then set whatever values you want to in the metric command. That's how you would bring in an IGP into BGP, and that's pretty much what I did on router 1. Is I was able to go in and I said redistribute Ospf into BGP, and that's how we're getting a bunch of RFC 1918 address space. Now, typically that's not how you're going to do things in the production, but you can do that in our example because of the fact that we're in a lab and it really doesn't make much of a difference. But in production, normally what you're going to do is the interface that you are peering to the provider with BGP, you're going to be NATing to that address. So you're going to be typing in your NAT statements, and you're going to say from anything from this particular range to this particular range, you're going to NAT to this particular subnet. And then everything will look like it's coming from one particular IP address or range, depending on how you have your load balancing set up or what have you. But there's a question, why would you want to include external Ospf? There are cases where you would want to bring it in. One in particular case I had with a client, they had Ospf as they were running Metro Ethernet, so basically a fiber circuit between two different locations, and they wanted to be able to advertise that externally as an IGP or as an IBGP route. So what we were able to do is advertise it in, and then use the backdoor command to change it from a EBGP route to an IBGP route, which changes the administrative distance command, or the AD on it from 20 to 200. So there are capabilities out there where you could do that. Where normally, if you're bringing in anything that's external to Ospf, sometimes it might already be BGP, so you wouldn't want to redistribute that in, but you can if you'd like to. The aggregated address statement requires one subnet in the BGP table first. The idea behind the aggregate, and we'll talk about this coming up later on, the aggregate is basically a summary. So there's a couple different ways you can advertise this. The aggregate address is a way for you to, if you just type an aggregate address, the mask, and whatever you're going to kick out. So, aggregate address 10.1.1.0/22, then as long as you have at least one 10.1.1 route in there, or anything that's going to be encompassed in that /22 subnet, as long as at least one route is in the BGP table, you'll be good to go. Now, the drawback to that is, unlike IGP summarization or aggregation, in this particular case, when you do a BGP, it's going to advertise both the aggregate and all the summary component routes, which means that if you have 15, 20, 300 routes inside of your aggregate address, it's going to advertise the /whatever in addition to all the longer matches. The way to get that to not happen is to go in and use the summary only command, which is only going to advertise the /whatever, /21 out for you. And then we have the Bgp Inject Map Statement, and so it's the opposite of aggregation. Well, this would be the similar to like EIGRP, when you would have a summary and then you would be advertising a leak map. The idea behind that would be you would create the summary address, whatever the summary mask is, so say a /20, and then you have a leak map configured attached to that, which would actually be calling a route map, which could then be calling a prefix list. So the layer of complexity gets deeper and deeper the farther you go with this stuff, but it's important to understand the logic behind it. I can take a look at some configuration after a couple of minutes and kind of get an idea of what's going on. And, I can say it's calling this, that's calling this, and then you can start putting this, okay, so we have this prefix list that is a /26 route. The route map is calling the name of the prefix list. The leak map is calling the route map, which is calling the prefix list. Pretty straightforward. But in order for all that to go together, you have to have all these components in place and referencing each other as they go along, and then from there you're able to go in and get everything situated. So the inject map is a way for you to advertise a longer match route into a summary to affect load balancing, or the way you're going to forward. So, because remember, when you're dealing with routing, regardless of which protocol, what the administrative distance is, longest match will always win. So the idea behind this is, if you have two different protocols, so actually we'll take that a step farther back. If you have two routes, they are both coming from the same direction, and one is a /22, one is a /22, you're going to load balance across both. Okay, that's the same protocol. If you have the same length mask to get to the destination, you're going to use both to get there. If you have a /23 and a /22, you're going to choose the /23 because it's the longer match. Now, if you have the same route, two different protocols, you're going to choose the protocol with a better administrative distance. So you would choose EIGRP over Ospf. You would choose BGP over EIGRP. And then you would go in, and that's how you would forward. Because AD beats out. Now, if you have two, remember, and then if you go to the same protocol and you have two equal match length routes, then you're going to load balance. As long as the route protocol supports it. BGP by default does not, but you can implement a configuration called Multipath, which allows you to load balance. And if you were to look in the BGP table, it would actually show up as you would have one best path, and then you'd have another path with they'd inserted M, which means it's multipath. And we'll take a look at that coming up here in a minute. I'll show you guys how that would look if we were to go multipath, because router 7 gives us the ability to multipath. So you have that in place. And then from there, the network statement is going to be the part that most people are going to be using pretty widely. And the reason for that is you can call the network statement and then have that's going to be what you use. So you have the network statement, and you go in there and you get all your component routes in, and you advertise what you need in. And now if you don't use the mask, so for instance you just type in 10.1.1.0 and hit enter, what's going to end up happening is it's going to advertise everything 10/8. Same thing with 172.16. If you don't specify a mask, you're not going classless, you're staying class full. And then by default it sets a weight of 32,768. So that actually clears up one of my best path selection issues as well. So if you have a network command, and let's say for instance you have a particular route where you're advertising via the network command, and you take that network command, you insert it, and then for that subnet you automatically advertise a weight of 32768. But ironically though, if you were to look at the best path selection algorithm, the locally originated routes is actually lower down in the best path selection algorithm than the wait command is. Now, this could be both, it's complicated for some people to grasp, but the idea is when you use a network command, you automatically tack on a weight of 32,768. You can go in and, with the wait command, specify that particular subnet and modify the weight up or down. The trick with this thing is, well, actually that's not 100% true, you technically can't. The idea behind the wait command is to affect how you're going to get off the network. So you wouldn't use it, you wouldn't use wait to affect how traffic would for a locally originated route. You would use the network command to advertise the route out. And this is the one thing where BGP gets a little different than IGP as well. With IGP, when you turn on the network command, you're turning the process on an interface that matches the network statement, and then from there you're able to go. When you're dealing with BGP, you form your control plane, you form your adjacencies, and then you advertise routes with the network command. So you use the neighbor command to form the adjacency, and then the network command to advertise routes. So in BGP, you're truly actually advertising routes. So yeah, and then you have that. So the idea when it comes to best path selection, or BPSA, and you're going through your motions, weight is going to be dependent on how you want to forward traffic leaving your network. So if you have a route that's on a different autonomous system, or your router is transit for some other system, so like AS1 wants to get to AS3, and you are AS2, and you want to affect the way that traffic is going to get to AS3, you can use the wait command to do so. So it's going to be transiting the router. And we'll talk about that more when we get into BPSA in the next video, but the idea is relatively straightforward. Then you have the redistribute statement. It originates prefix with the origin incomplete or the question mark. So it originates classful summary into if auto summary is enabled, which by default in our syntax of 15.x code and later, it's automatically disabled by default. So if you want to turn on auto summary, you would have to type in auto summary and then hit enter, and it would automatically summarize. The other thing too is it automatically copies the IGP metric to the BGP med. Now what that means is, and this is for locally originated routes, med, or the multi-exit discriminator, is just the metric value that you're going to associate to a route. Now med is optional, it's an optional transitive attribute, which means that it only handles the next hop up. Meaning you're autonomous system 1 and you're trying to get to the say, yahoo.com. Well, you need to go through AS2 to get there, because yahoo.com is, let's say, AS3. You could configure AS2, which is between AS3 and AS1, to advertise a different metric value for the Yahoo route, which we'll say for Yahoo is going to be 10, 10, 10, 10. Okay? You can advertise the 10, 10, 10, 10 route from AS2 from router 2 and router 3 down to AS1 on router 1. The idea behind that is that when router 2 advertises the route to AS1, it's got a better metric, which means it's lower. The lower metric wins here. And I know I'm getting way ahead of myself inside the best path selection algorithm, but I figured it's applicable here. When you have the med coming in, that's the metric value. Then you could have router 3 advertising the same route to router 1, but with a med of 300, which is a higher metric. The idea here is you're going to choose path to router 2 first. If router 2 goes down, you're going to choose the path to router 3. So it gives you a high availability failover capability built into BGP if you need it. And typically, MED like AS path is going to be used to affect the way you leave the network. Actually, sorry, not AS path, local preference. This is how you determine how you're going to leave the network. So, local pref and MED determine how you leave the network. AS path and what's the other one? I forgot. We'll come back to that later. But the idea behind the whole idea behind the MED is to modify the metric command. So when you see that, you'll see several routes. And actually, I can show you what I'm talking about. If you look right here, see all these times where you see a 3, you see a 66, you see a 100, or I'm sorry, a 66. That's the MED. This is the metric. And the reason why it's 0, or it's got a number in there, is because the routes were all redistributed. Notice there, the routes all have the question mark. The question mark means it was redistributed into BGP. And therefore, whatever the metric value was at the time of redistribution, that's what's copied into BGP. But the thing is with that, the MED value is local to the autonomous system you're working with, unless you're trying to affect it outbound and you're trying to advertise it out to somebody. And we'll take a look at that coming up later on. But the idea behind that is if you don't need it, you don't use it. And MED's pretty far down in the BPSA, so typically it's not widely used. But that's where the MED comes into play. Again, if you want to redistribute OSPF into BGP, you need to use the Redistribute OSPF match external in order to get that in there. And again, redistributed routes advertise a set of weight of 32768. And then we have redistribute internal. What redistribute internal means is basically when you receive BGP updates, you're only going to redistribute external BGP routes into IGP. Now, if you want to redistribute internal BGP routes, you can as well. But remember, BGP internal routes are going to be an AD of 200, which means that you're going to more than likely have an IGP with a better administrative distance to that route already. So that's going to be your key factor in how you get that situated. But you can do that, but you can cause a routing loop. So if you want to be able to redistribute iBGP into IGP, the way to do that would be to type in BGP redistribute internal, and that's going to allow you to redistribute your iBGP routes into your IGP, and they'll show up. But I've only practiced that once just to see if it would work. It did. It just added another path for me, and I didn't really need it, so I just wanted to see if it actually would work. Now, the one that's kind of interesting is the BGP network backdoor. Now, the backdoor, basically what that means is you're learning a route from somebody else, and let's say for instance you've got a backup network. So you've got your main dedicated internet connection that's BGP, but then you also have a backdoor link, say for instance like a 10 gig or a 10 meg or 100 meg or gig fiber link between two different, like you and a backup site. And you want to make sure that that backup link is only used in case the primary one goes down. So the easy way to do that would be to, you're going to advertise that particular subnet through BGP, and it's going to be learned by the other BGP neighbor. And then what you're going to do is, once the route is learned by the other neighbor, you're then going to type in, the network command, and then whatever the subnet, whatever the prefix and the length is, and then you're going to tack on the backdoor command at the end of it. The backdoor command will move it from to an AD of 200, and it'll be referred as a backdoor. So it'll look like an iBGP route over an eBGP route. Even if it was learned via eBGP, it'll look like iBGP in the table. And therefore, it would only route over that if the eBGP peering went down. And then we have the dynamic neighbors. The dynamic neighbors is pretty straightforward for the most part. The idea behind the dynamic neighbors is to be more IGP-like. So what you do is you create a peer group, and that peer group is going to have a remote whatever attributes you need to put in there. So like the remote autonomous system number, any specifics like the update source is different, or route reflector client, things like that. And then what you do is you type in the BGP listen command, and the listen command, you're going to give it a range, and the range is going to be asking you, who should I be listening for? So let's say, for instance, you already have the public IP address base of, say, 100, but you have spoke sites that are 101, 102, 103, 104, all /24. So you would go in and you would set that up to where it would listen for the range of 101, 102, 103, 104 /24, and then from there, if you received a BGP message from any of those guys and their source address came from that particular subnet, then you would accept the route, and then you'd be able to form a dynamic neighbor. I have tried this with MPLS VPN, and it gets kind of hairy because of the fact that it doesn't change the update source. You have to manually configure that, and I will. It's a little outside of our scope, but MPLS is not inside our scope. I'm just going to talk about the general idea of what the different configs are and how that would work. Same thing with multicast and quality of service. Neither of those are on our blueprint, but I'm still going to cover them at least at a high level so you guys are familiar with what multicast and quality of service are as we go along. And you got conditional route advertisement. Now, I'm not going to go into very much detail about this, but the general idea of conditional advertisement is that when you have you're going to have an advertised map, and you're going to have an exist and a non-exist map. The idea behind these two is very simple. If you have a route in the routing table, an exist map is going to match that particular subnet. So you're going to have a route map that calls the route that's in the routing table. The routing table, as long as that route is in there, let's say for instance you have a route to Google DNS, so Quad 8. You punch this guy into the routing table, or you create a route for it, and the prefix list is calling that. The idea behind this is, if you go in, if the route exists, you're going to advertise the default route. This is the most common way I see it. Now, if what ends up happening is you're going to also configure a non-exist map. The non-exist map is also going to be calling the Quad 8 route, to where if the Quad 8 route is not in the routing table, the non-exist map attribute is true, therefore you're going to remove the default route. So the idea behind that is if you have the route in there, so the idea is it's going to be a way of actively tracking what's in the global routing table. So this is going to be a conditional default routing, and then which is a step short of reliable conditional default routing. Now, what does that mean? Reliable conditional default routing simply means that you're going to create a IPSLA instance to ping a particular subnet or a particular IP address. You're going to attach that to a tracking object, and then you're going to attach that to a route in your routing table. And then from there, if the SLA instance fails, the route is pulled for the default route is pulled from the routing table, and then you no longer have reachability. The moment that route is reachable, it's a true statement. You are actively tracking it. It's then back up again, and then it's going to be in the routing table. Then you can advertise your default route. So that's a high-level overview of how that would work. Now, I'm not going to get into all the details of how that stuff works, but it can be kind of tricky on how it breaks down. But the idea is relatively simple, relatively straightforward. So you've seen me use the network command. You've seen me use the redistribute statement. I'm not going to go into much more detail than that. I don't think it's really applicable for us, considering I've already done it several times. The next video we're going to do is going to be getting into the BPSA and talking about how the different attributes work. We're going to start off with the weight, then we'll talk about local preference, locally originated routes, AS path prepending, med, and I think that should wrap out the top 6. I think will be fair, and then that'll wrap up BGP, and then I will do one for aggregation, and that should pretty much be the end of it. And then we should be able to move on to all of the to DMVPN and GRE and get the tunneling situated, because you can't really understand DMVPN before you know GRE tunneling. So I hope this has been informative for you. I would like to thank you for viewing.